Holy cow, I'm loud. How was your lunch? Was it good? Yeah, lots of choices, lots of lines, good food. Thanks for coming out to this talk. I've been playing with it for a while. My name is Richard Campbell. I'm from Canada, although I was born in New Zealand, and I sound like an American, so I don't know what to tell you about that. I make some podcasts. Any .NET Rocks listeners in the room? Oh, wow, okay, quite a few. So my friend Carl Franklin started the show .NET Rocks back in 2002, which predates the word podcast by 3 years. I came on as co-host in 2005, and we've got about 1,660 episodes done. And this show, this talk actually comes from .NET Rocks. We do a series of shows called Geek Outs. Anybody listen to Geek Outs? So we've made a lot of them, about 80 of them now. And this particular talk comes from the moon-based Geek Out. So I had read some papers about the Europeans talking about wanting to put a base on the moon, like similar to an Antarctic base, that it would be a research base and what it would actually entail to do that. And I thought, well, that'd be kind of cool to do a Geek Out around, and the listeners seemed to like that. So I made that show. And then that summer, I got a phone call from NASA, which is a good day, right? Like. Let's be honest, actually. I got an email from NASA first, and I deleted it, because who gets an email from NASA? Anyway, the check was persistent, sent it again. I did get on the phone with him. He said, hey, we really like your podcast about the moon. I'm like, cool. It's like, would you ever think about doing it as a talk? Yeah, okay, yeah, I'd do it as a talk. For who? Well, for us. It's your stuff. Yeah, we know. We like the way you tell it. We'd like you to come and tell it to us. Okay, so you want me to tell you your stuff. Okay. So in the fall of 2017, I went down to the Ames Research Center outside of San Francisco, and I did an hour-long presentation on building bases on the moon. And my mother is proud. You know, you go drive up to a NASA research site, and there's a big sign outside with your name on it. That's a good day. So, but I made a lot of changes to that because stuff's happening. When I was writing that talk in the beginning of 2017, and even here, it wasn't anywhere near as much in the news as it is today. And so I literally added material today from press releases from NASA this morning in America, which would actually be yesterday morning, but let's not get technical. Of course, I have a soft spot for the moon. I imagine you do too. This is one of my favorite photographs of the moon for a bunch of reasons. One is that it's actually a picture of the far side of the moon, right? Not the dark side of the moon, because clearly that's not dark. The moon is in a tidally locked orbit around the Earth. The same side of the moon always faces us. This is the other side. And the question you ask, I'm always a suspicious sort of person, because we deal with a lot of science fiction, a lot of sort of created like CGI stuff. So when you see a picture like this, the first question that hits me is, who took this picture? Because that's a funny spot to be, right? And this picture is actually taken by a satellite, a solar observation satellite called Discover, and it is about 1.5 million kilometers away from the Earth. And it's actually, the main part of it's focused on the sun. It studies solar emissions and solar storms to give us warning to protect our satellites if there is a major coronal mass ejection or any other kind of solar storm coming at it. And somebody was smart enough to put a telescope on the other side of the satellite. Because when you're 1.5 million kilometers away from the moon, the sun is really not that big. It's a teeny, just a few arc seconds across. And so they have quite a good telescope aimed right at the Earth. And it takes pictures every few minutes and sends them back to the Earth. And every so often, the moon whizzes through the frame. And like whizzes through the frame. In fact, so fast, if you get a really good look at this picture, if you ever get a copy of it, you'll notice that the right side of the picture of the moon there has a little green haze. And you're like, why? Why would it have a green haze? Well, cameras in space aren't the same as cameras at home. This is actually a monochromatic camera. It's a big CCD receptor, and it has different filters that are really designed to look at different kind of weather conditions and plant states and so forth. And so to actually make a color photograph, they need to take 4 pictures with different filters on it, and in that time, the moon moves. And so the reason you're seeing the green halo is that the green filter was shot last. And so the moon had moved a bit there, and it's a distortion which is one way of me sort of looking at it and going, this is very real because of its imperfections. You know, with CGI, there wouldn't be a green haze. This is a real picture. Now, the moon is back in the news again, which seems odd because we've already been there, right? There was the Apollo missions back in the 1960s and early 70s. This was a competition between the United States and the Soviet Union, largely driven by the Cold War. And this, by every measure, was a military mission, right? NASA's typical budget from the United States government is about 0.5% of GDP. Right? It's not a tremendous amount of money. But during the Apollo missions, during that 7 years where they built out those Apollo rockets and flew men to the moon, it was 5%. So this huge budget increase. And once they'd achieved the goal of putting men on the moon, the budget got cut and pretty quickly everything shut down. So 12 humans walked on the moon. You will notice they are all white men. They are also, 11 of them are military test pilots. Right? This was actually a military mission. That's why they were military test pilots. There's one exception. It's the fellow in the bottom right-hand corner. His name is Harrison Schmitt, or Jack Schmitt, he preferred to go by, and he is a geologist. He was originally supposed to be on the Apollo 18 missions, but when they cut that mission, there was a lot of pressure to put at least one scientist on the moon, and so they moved him up to the Apollo 17 missions, and so he was the only non-military professional to set foot on the moon. There he is. And a few things to notice about Jack on the moon. First off, he's filthy because he fell down a lot, because he kept wanting to look at rocks, because he's a geologist. If you ever get a chance, of course, NASA is this public entity, and they've literally published everything they did on the moon. Everything is available, and you can listen to the entire audio stream of their conversations on the moon, including where NASA kept telling Jack to close his sun visor, right? They're up there with no atmosphere, the sun, the pure raw sun beating down, like it will burn a hole through your retina. He kept flipping up his visor because he wanted to look at the rocks, because he's a geologist, right? You notice on the side of his helmet, there's all these little white things. He took reference cards off his sleeve and stuck it in his helmet so that he could block the sun better, so he could look at the rocks, because he's a geologist. You know, humans are at their best when they are exploring, when they're pressing against the edge of it. This was a professional geologist, and he was looking at rocks that nobody had ever looked at before, and little technicalities like having his eyes burned out of his head was not going to interfere with that. And so you hear over and over on the stream, it's like, hey, Jack, when you get a sec, would you close your visor, please? It's also one of the few times there's a couple of photographs of him with the visor up, and so you can actually see there's a face in this giant suit, and he's smiling, right? He's exploring, and he found some of the most important rocks of anyone that went to the moon. This rock, they argue, is the most important rock. It's about this big, but you know, size isn't everything. But this is they call it the most interesting sample ever returned from the moon. It is an unshocked piece of olivine. And if you were a geologist, you'd be like, wow! Everybody else is, it's a rock. Why is an unshocked piece of olivine important? Olivine is only formed under high pressure. So this was a high pressure rock. Now, typically, you find olivine on the moon, it is shocked olivine. It has been created by an impact on the moon, by an asteroid impact. This wasn't that. This was formed volcanically. So one of the theories about the creation of the moon is that during the early stages of the creation of the Earth, there was a collision between a Mars-sized body and the Earth. This is called the Thea theorem. And that impact created a spray of rock that formed into the moon around the Earth. And that it was still hot enough that it created a molten core and compacted itself and had a magnetic field, and there was volcanic activity on the moon for some period of time. And this rock is proof that there was enough time in the formation of the moon before it went to cold that it had volcanic activity that was able to form high-density rocks like olivine, and it was able to throw them up onto the surface of the moon in a volcanic detonation of some kind. So a very interesting piece of science that came from what was otherwise a military mission. Now, at the end of the Apollo missions, we went down there successfully 6 times. A lot of folks sort of wrote off the moon at that point. It was kind of a cold, dead rock. But these are the only spots that we landed. Now, these landing sites are all on the near side of the moon for a couple of reasons. One was they wanted to stay in contact with the Earth. So being on the near side, that made that possible. They also only wanted to land during the day. It's 14 Earth days of daylight in the equatorial location on the moon, followed by 14 days of darkness. And so they timed everything to have it during the day. The furthest 2 points here between Apollo 12 and Apollo 17 are about 1,600 kilometers. So they've only, and it's relatively equatorial, sort of in the middle of the moon. That's also limitations of the lander. They couldn't land much further north or south. It just, their technology wasn't advanced enough. It was the 1960s. And it was a race, right? They had not built this to last. They had built this to beat the Soviets. And there were no survivable failure modes on the moon. If anything had gone wrong with that lunar lander had supplies to keep 2 humans alive for about 3 days. And the fastest you could launch a backup ship to get it to the moon, 3 days. Which is one of the reasons they stopped. It was very, very risky. And they got lucky. They still had some deaths and some near disasters, but nobody ever got left behind on the moon. But that small amount of area, that oval that they searched in, the equivalent oval would be the Sahara Desert. So imagine if you were exploring the Earth and you put down every mission in the Sahara Desert. How much do you know about the Earth at that point? So we only looked at a small part of the moon in this brief race 50 years ago. But we kept going back. In the early 90s, there was a mission nicknamed Clementine. It was an experimental spacecraft testing a bunch of new technology, and it flew and orbited the moon for a little while. This is the 1990s, so we fast forwarded 20 years. And they bounced radar off of the moon repeatedly, and they got very odd reflections from the poles of the moon. It was the first hint that there's something weird on the poles of the moon. And so about 6 years later, with Lunar Prospector, they flew a gamma ray spectroscope. So this is a device designed to bounce gamma rays off of the surface of an airless moon and get back spectra that allow you to tell you what minerals are there. They found a lot of interesting things. They found concentrations of potassium, rare earths, uranium and thorium, and hydrogen on the poles, which is weird because hydrogen is a volatile. It shouldn't be on the poles unless it's made into something else. And that's where the proposal that it might be water really started, was with Lunar Prospector. Fast forward another 10 years. In 2009, they fly the mission, the Lunar Reconnaissance Orbiter. Now, this spacecraft was designed to operate for a year, and it's still operating to this day. So it's more than 10 years old, and it does detailed mapping of the moon. And you've seen Lunar Reconnaissance Orbiter photos, whether you know it or not. All of these high-resolution pictures, it's mapped every inch of the moon down in very, very great detail, including the Apollo site. So if you've ever seen these pictures where they can actually see the footprints and the descent stage and so forth, these are all LRO photos. So over 10 years, it has repeatedly photographed the moon in great detail and done most of the most intricate scanning that we've ever had. And typical of these Ames spacecraft, it lasts a long time. There was another payload on the LRO mission. It was called L-Cross. And when I did that presentation at Ames, I talked a lot about this mission because it was done from Ames. So they were there. The LRO, the Lunar Constants orbiter, ended up being slightly bigger than expected, and so it needed a larger rocket than they originally planned on. They originally planned on flying on a Delta II. They ended up flying on an Atlas V. And as a consequence, they had leftover payload. They had extra capacity. And so they kind of, with a limited amount of time, they said, what other mission could we do with this little bit of additional payload? And of course, the question on everyone's mind at this point, with all of this potential evidence, is can we prove there's water on the moon? How would we do that? And this is the idea they came up with. We're going to take the second stage booster. So this is the Centaur booster. And we're going to fly it into the moon with great velocity. Vigor, they call it. But into a continuously shaded crater. So a crater that's never had any sunlight shine on it. And kick up a dust plume. And then we're going to send a sensor array through that dust plume and measure what's in it. So the Centaur booster, if you're trying to get a sense of size, is about the size of a large school bus. It's mostly an empty tank, but it has engines on the end. And the controller bus, which they call the spacecraft bus, is about the size of a Mini. And it was actually a modified microbus, satellite microbus. And it had a set of sensors on it, including a sensor that literally was designed to have debris impact on it and take measurements from it. And so they repeatedly orbited it between the moon and the Earth while the LRO was doing its detailed mapping for a better part of a year until they figured out this perfect location in the Cerebus crater. It's like, here's this continuously shaded area. We're going to put it down right there. And then about 4 months before, they actually separated the two spacecraft so that the Centaur booster, the bus, would hit that point, exact point on the crater and kick up that plume. And 6 minutes later, this sensor array would fly through that plume and also meet the moon with great vigor. And it worked. It kicked up a great big plume of debris, and they were able to do a set of measurements. And what they found in that continuously shaded area was all kinds of hydroxyl radicals, ammonia, frozen carbon dioxide, and about 20% water. Like a lot of water. Exciting, right? And then it was very quiet. You know, there was no good outcomes for these guys, but at least they did their jobs. And so we begin to take maps of all these shaded areas, both in the North and the South Pole, presuming that there's water now concentrated there. We're not entirely sure why the water is there. We just are pretty sure that it is. And we don't know exactly what form it's in. Is it crystals? Is it chunks? Is it dust? Is it contaminated with other chemicals? So there's another set of missions they have to do to try and figure out what to do with this. But if their calculations are correct, it's hundreds of millions of tons of ice, which suddenly makes the moon a lot more useful. Water's needed for everything that humans need. And so if we have water, we've just made working on the moon a heck of a lot easier and may make it actually a useful resource for anything else we want to do in the solar system. One more mission they flew roughly in the same time span, it's around 2011, was the Grail mission. And I bring it up because it actually has an impact on a lot of things. If you've ever watched or heard the story of Apollo 11, you know that right towards the end of the landing, Neil Armstrong took manual control of the Lunar Lander to avoid a bunch of house-sized boulders, and he flew it by hand like the test pilot he was, and touched down with 20 seconds of fuel. The real question you have to ask is, why? Why did he do that? The reason is that they were long, and they knew very early on. They've actually listened to the whole Apollo 11 landing sequence, which is about a half-hour long, from when they separate from Columbia and begin their burns to come down and land on the moon. They're taking measurements the whole time. And within a few minutes of the separation, a half an hour before the landing, they're like, we're crossing marks too soon. We're long. And they landed past their original safe landing site over to another set of craters, including this place with the boulders, which is why he had to fly by and land on that. The reason they were long is that gravity on the moon is erratic. There is a non-trivial amount of variation in gravity from point to point of the moon, plus or minus 2%. And so the area they were flying over had just a little bit more gravity and accelerated their ship a bit more, and it threw them off by kilometers. So in 2011, they flew a mission called the Grail mission, which was 2 satellites flying in formation, where the back satellite would watch the front satellite's fluctuations in movement due to the variations of gravity on the moon. And so they were able to take a gravity map of the moon and figure out how big these variations are. This helps us address a really challenging problem if we're really going to hang out on the moon, which is, can I land in the same place twice? Because if you want to build a base, you kind of have to be able to go back to it. And this was one of the things we needed to understand, is that the moon, mostly we believe because of meteorite impacts, large meteorite impacts, have significant mass concentrations relatively close to the surface, enough to literally distort the gravity of the moon. So plus or minus 2% adds up when you're doing orbits. The folks at Ames had another mission. When I was there in 2017, we were talking a lot about it. It was called the Lunar Prospector mission. The goal was to land a small, inexpensive lander right near one of those continuously shaded areas, then drive the rover into the shaded area. They had a neutron scanner in front of it so they could look for water concentrations in the regolith, in the dark spots, dig some up, come back into the light where the solar power is, heat it up and see if they could separate out the water. They wanted to get the basic set of rules of what it would take to extract water from whatever state the water ice is on the moon. It's a cool idea. There's lots of concerns here, like the water might be heavily contaminated. Now, they did detect things like ammonias and peroxides in that spray from the LCROSS mission. You know, water's fun, but not when it has ammonia in it. This mission has been stopped. It's been canceled. Now, that's not a good thing. I hate it when missions get canceled, especially ones that I want to talk about. But they had already a rolling prototype of this, and NASA never throws anything away. So one of the reasons it was canceled is the new administration was changing the priorities around the moon, and they actually want to order commercial missions to do parts of this. And so NASA will basically make the components and plans available to anyone who's actually going to fly a mission to the moon. And so NASA's now got open bidding for putting rovers on the moon, multiple rovers on the moon, and this would be one of the things they could do. So rather than having NASA build it, there's other people building it. But NASA hasn't landed anything on the moon. There's been a few other orbital missions in the past few years. But if you've been paying attention to the news, you know that other countries have been going to the moon. China put down the Chang'e 4 lander late last year on the far side of the moon, which is the first vehicle to ever land on the far side of the moon was this Chang'e 4 lander. And again, asked the appropriate question, which is, who took this picture? This guy took the picture. And that's the rover called the Yulu 2. It's just a little rolling rover, and it took the picture. They took pictures of each other, as you do, space selfies. Actually, there was recently some news that the rover found an unusual material in a crater. They said it's a gel-like substance, which seems unlikely. It's possibly it's glass. They're talking about what it is, but the Chinese don't have the same policies as NASA, where they have to publish everything that they find. The Chinese are talking about that their little rover has found something interesting. A part of this mission, of course, to work on the far side of the moon is that they actually need a relay satellite. So the Chinese are now have a long-duration relay satellite flying off the far side of the moon to be able to get the radio transmissions from the far side of the moon back to the Earth. This almost feels like infrastructure, right? Like the beginning of a cellular network for the moon. It's just owned by the Chinese, so what could go wrong? And just to be sure the Chinese really did it, this is the Lunar Reconnaissance Orbiter's picture of the lander and the rover. So, you can argue as to how much we're getting along with the Chinese or not, but we can take pictures of each other's stuff. Also in the news this year, a company called SpaceIL out of Israel made the Bereshit lander. They flew it off the back of a Falcon 9. It was one of the smallest landers ever built, very low cost. And it didn't work out too well. They got it to the moon. They attempted a landing. To their credit, they literally were live streaming the entire landing process the whole time, so you could watch them as they lost control of their lander. The Lunar Constants orbiter has been able to photograph the site where it landed. I don't know how mean this is. Actually, it's like, hey, found your lander. But, that's the nature of the moon, right? Anything you put down there, they're eventually going to find the mark, so to speak. And just even more recently, the Indian Space Agency flew a lander and an orbiter around to the moon. The orbiter's doing just fine. The lander, only a couple of kilometers away from the surface, also they lost control of it, lost communication with it. They haven't found it. So this is a Lunar Constants orbiter of where they were looking on September 17th. The LRO flew over the expected landing site, and these are the photos they took. It's somewhere in here. If you can see it, let me know. But they haven't been able to find it, and in fact, the next pass of the LRO into that area was yesterday. So we maybe the next day or two might have that same nice matched image of found your lander. Let's talk a little bit about NASA. So NASA has been doing more commercial-related programs, and they're certainly doing a lot of commercial programs around the moon. So the space station itself was built very much as a government project, an international outreach project, a lot of different countries working on it. But a number of years ago, they started doing commercial resupply. So this is where SpaceX and Orbital ATK were flying missions to put supplies to the space station for a fixed rate. So essentially, for this much money, you will fly this much payload up to the station and potentially payload down to the station. How you do it, not our problem. This is different from the way that space agencies, especially NASA, typically contract things. The normal way that they contract projects like moon missions is cost plus, which is we will pay whatever it costs you, plus a bonus if you make certain deadlines, just get it done. The downside to cost plus is you're incented to make sure you succeed irrespective of how much anything costs. So you tend to have cost overruns as you carefully test and carefully test and carefully test. Even if you miss a few deadlines, it's probably better to test some more, right? Where if it's essentially a flat rate, then you're incented to reduce costs, which is why the commercial programs have worked as well as they have, at least for the resupply of the space station, and now soon manned transport to the space station will also be on similar kinds of contracts. And so NASA's announced a bunch of missions around the moon also using commercial contracting. So the bidding is open on a bunch of different projects. Meantime, they're building their own rocket. This is called the Space Launch System, and it looks vaguely like the Space Shuttle. There's a reason. It is mostly reused Space Shuttle parts. So the Space Shuttle program stopped in 2011, but even before then, they were talking about trying to build a more powerful rocket, something the Space Shuttle could lift about 27 metric tons into low Earth orbit, which is not enough to do anything beyond low Earth orbit. It was enough to assemble a space station, one 15 to 20 ton piece at a time. This is a much more powerful rocket. It uses the same kind of engines as the space station, as the shuttle, but more of them. And it, in its larger configuration, could push about 100 tons to low Earth orbit. That is getting into your Saturn V class of rocket. I think this rocket would be very cool and very exciting if it was 1990, right? Which is really when they first started drawing pictures like this, of we could make a rocket like this from these parts with heavy lift. You know, it's interesting to think in terms of the space shuttle is a 100-ton vehicle. If they had just made the whole thing payload instead of a returnable shuttle, they had a 100-ton lift rocket, which is why they're coming up around 100 tons worth of lift when they get rid of all the vehicle stuff. Like, it kind of makes sense. But as soon as you start playing with SpaceX and things like this, it seems awfully archaic. And for a long time, this project existed almost more than NASA wanted it to. It was mostly the US Congress that kept it alive, kept funding it, because it keeps a lot of people employed to keep playing with these parts. But they have a mission now. Since the interest in the moon has increased, one of the proposals is to put a small space station in orbit around the moon. They call it the Lunar Gateway. And if it looks vaguely familiar, the parts look somewhat like space station parts, it's because they largely are. Now, there's a bunch of things we've learned from the International Space Station that we'd probably like to apply in a new station, mistakes that were made, starting with things way too big. Actually, a smaller station is a little easier to manage and maintain. So this would be a station that could keep 4 people comfortable for 60 to 90 days at a time. But that also means it would spend a non-trivial amount of time unoccupied. And so it needs to take care of itself. And if it's going to orbit around the moon, that means it needs to be able to maneuver itself and so forth. Because of that gravitational irregularity in the moon, putting important things, heavy things, in orbit around the moon in any conventional orbit, typical polar orbits or equatorial orbits, they decay very quickly. You typically don't last a year, unless you do station keeping. But a group of clever scientists came up with an orbit for the moon called the Near Rectilinear Halo Orbit. And Diane Davis from the Johnson Space Center, I encourage you to look this up to see the original video of this whole thing. This is the orbit they want to use for the space station. And the easiest thing to understand is the top right there, where you see the space station is flying very close to the moon on the North Pole, and then it flies a long way from the moon to the South Pole. Over and over and over again. It's about a 1-week orbital period. But for 6 of the days, you have a great view of the South Pole. And then the other day, you whiz around the North Pole. Also, you're always in view of the Earth, because you're actually orbiting in the same plane as the Earth and the moon. So you always have a view of the Earth so you can communicate, and you always have a view of the sun. So you don't have the battery problem, right? The International Space Station is 45 days of sunlight, 45 hours in sunlight, 45 minutes in sunlight, and then 45 minutes in darkness. So charge batteries for 45 minutes, discharge battery for 45 minutes. But in this orbit, the Lunar Gateway would be in the sun all of the time. So a pretty useful orbit, and it gives you this very long duration view of the South Pole. So if you want to operate robots down on the surface, if you want to communicate with folks on the surface down on the South Pole, you can do it very easily from the Lunar Gateway. Plus, we know how to fly to a space station. We know how to get commercial contracts onto a space station. And oddly enough, once you put a space station up, it's hard to ignore. You know, one of the challenges that the Americans have is they keep changing presidents, and every time they change a president, they restart a space program over and over. So they tend to talk about space programs a lot, not build very many things. So I think the Lunar Gateway is also a way to deal with the inter-presidential transitions, where it's, we have a station, maybe we should keep supplying it and maintaining it. So this initiative is called Artemis, Artemis being, in Greek mythology, the twin to Apollo. Clever. And just last month, the Australian Space Agency, yes, you have one, has signed on to the Artemis program. I'm making fun. Look, I'm a Canadian. We make robot arms. That's about it. We're good at making robot arms, though. They've been on all the shuttles. They've been on the space stations. Like, we'll make robot arms for the Gateway, too. And of course, the Australian Space Agency famously has all of the deep space antennas. Right? They tracked every manned mission, Mercury, Gemini, Apollo, the space shuttles, all of them, and participated in different engine developments, and they are going to participate in Artemis. So part of the same program. We're with you. We're all going together. It's going to be fun. The current US administration has compressed the timeline for Artemis with the goal to land a man and a woman, they tell you that all the time, onto the moon by 2024. This is, by all accounts, a bit rushed, and this is their sort of how we're going to do this, where they have a bunch of commercial missions, landing rovers to do exploration on the moon, sort of make sure they got the right sites and so forth. They've now put out to tender for different kinds of landers, and they're going to build the Gateway as sort of staging ground to go down. Although now there's conversation about, should we really build a Gateway? Why don't we just get the lander and just fly directly to the moon? Which is great if you just want to get to the moon to take a picture. Right? The sort of flags and footprints missions, as opposed to starting to build some infrastructure that actually leads to us becoming a spacefaring civilization, right? Putting up stuff that we can use over and over again. Remarkably, for as quick as this whole conversation has happened, NASA has already ordered a component for that space station. It's the power and propulsion unit. They ordered this. They actually ordered 2 of them from Maxar. They're about 10 metric tons. They use Hall effect thrusters, basically ion thrusters, which is just as cool as you think it is. These solar panels here are what they call ROSA panels. They're about 30 kilowatts each, which is 3 times more powerful than the panels that are on the space station. They're also much bigger. And the reason they were able to order this so quickly is they've been working on the design for more than 10 years. And the previous time that they were looking at this exact design was from the previous administration, where they were doing the asteroid redirect mission. Anybody ever hear about this? NASA was going to send a robotic spacecraft out to capture an asteroid, bring it back to lunar orbit, and then they were going to fly an SLS with some astronauts up to it to check out the asteroid. And that mission got canceled in 2017, roughly a first year of the new presidency. Ta-da! But that little module right in the middle, let's see if my pointer can do the trick. Oh, this is the wrong button. This little trick. There, see that little module there? That's the same module. Right? It's an ion thrusting module. It's using a different set of antennas. These are called ATK Megaflex antennas. About the same power, just a different company. But for the same reason, a long duration, low thrust maneuvering unit that you can fly into deep space for extended periods of time. Exactly what you need for a station around the moon that's going to need periodic station keeping so that it can last on its own. The one thing that our big International Space Station can't do. The space station's always losing altitude. Even though we're fairly high out of the atmosphere at 400 kilometers, it's not high enough. And so every time there's a spacecraft visiting it, before it leaves, it does a little reboost. Lifts the orbit of the space station a bit each time, and then they leave. That same design could go into cargo transport between the Earth and the Moon. So this is a design from Lockheed Martin called Jupiter. And so it would very much the same kind of resupply missions. But now, because you're just flying in space between the Earth and the Moon, you don't need the high-powered chemical engines. You can use those Hall effect thrusters and possibly use it repeatedly. So you can imagine having a cargo container that's met by a low Earth orbit spacecraft like a Falcon 9, and it picks up that cargo, and then it uses its Hall effect thrusters and flies it to the Moon, gets to the space station, they unload the fresh supplies, load up their garbage supplies, and then it flies back, lets that cargo container re-enter and burn up, but the actual maneuvering unit then picks up another one and flies again. Like a bus, or cargo, infrastructure, stuff we would use over and over and over again instead of one-time missions. All right. This is the new design, proposed design for Lander. So this was only last month that NASA put out, actually it's the beginning of this month, they gave 30 days. By November 1st, you have to submit proposals to provide a lander to NASA that will support 2 humans, one of them possibly a woman, they'll keep telling you that, to land on the surface of the moon and have them survive, sufficient food supplies and so forth, for 6 days. Doesn't require to be reusable, but they would prefer it to be reusable. They'd like it to have more duration as possible, and there's about a dozen companies that are bidding. They're supposed to have bids in by November 1st. Many of them you've heard of, like SpaceX and Boeing and Lockheed Martin, but there's other ones like Orbit Beyond and Aerojet Rocketdyne you may not have heard of, but there's a bunch of companies bidding. And only today, they announced the new suit designs for working on the moon. So they have 2 new suit designs, and this was a picture of one of them. Few things I want to point out on this picture, because they didn't do a lot of explaining about this picture, but there's a lot of things you should look at. I mean, first is recognize the lander. It's not too different from the one I showed before, except they have 2 sets of megaflexes, because this is one admitting that the habitable stage, which is right at the top, that little device, would separate and fly off and leave the landing stage behind. The landing stage is enormous. That's a good, 20 meters high, so don't trip. But actually, the most important thing to look at is that this astronaut is kneeling, something that no Apollo astronaut could do. Spacesuits are tricky. They're pressurized, right? They've got air around you. There's no air on the outside, so you're basically in a balloon. And that balloon kind of wants to stay straight. And so if you ever watch Apollo astronauts wandering on the moon, they sort of, and a number of times, because Harrison Schmitt bent over the most because he likes rocks, he would lose his traction and fall. And then to get back up, he would use a stick and he would sort of push himself and bounce back to his feet, because it's only 1/6 gravity. And they'd say, "Be careful, Jack," and then put your visor down. So can they actually kneel? I mean, that's kind of a big deal. They could build a suit now with enough flexibility that you could kneel and have more maneuverability. The other thing they showed off today was somebody wearing the prototype suit, and she was able to reach all the way to her other shoulder, like this, because the Apollo astronauts, it's hard to move in these suits. Yeah, and another aspect of the suit is it's a one-piece suit. And if you ever watched the movie The Martian, you can't put on a spacesuit by yourself. It's a giant lie. It takes at least 2 people, usually 3. It's really physically difficult to put a spacesuit on. But this suit design, one of the ideas on it, it could be a one-person suit. And so the back opens up and you sort of climb into it and tuck yourself in and put yourself up and then close the back on it. So trying to get to science fiction level suits. All right, enough about NASA. Let's talk about the crazy guy. I love a good tech billionaire. He's always good for a laugh. No doubt he's built some pretty cool rockets. Of course, he's all about Mars, right? He's been talking, Elon's been talking almost exclusively about making humans a multi-planet species. I like the goal. It's a good goal. I think he's a little optimistic. Okay, he's a lot optimistic. But when the excitement came around the moon, he pretty quickly showed up pictures of SpaceX stuff on the moon. So he's willing to come. And of course, this is a model of what they call the Big Falcon rocket. You can use whatever acronym you want, which seems ridiculous until you see this. He built it, right? It doesn't do anything. It's just a piece of stainless steel in the desert right now. But he's building it. They're now calling it Spaceship, or Starship, which is a little optimistic. But, you can't argue with the man. He builds stuff. And everybody loves Falcon Heavy. And a lot of folks are wondering why he wouldn't put more energy into Falcon Heavy. It's supposed to have a tremendous payload capacity to orbit. And the real issue, and the reason he's basically ignoring it, he doesn't talk a lot about this, is a thing called the fineness ratio. So when he originally proposed the Falcon Heavy was when the Falcon 9 was a much younger rocket than it is now. It was shorter. So the fineness ratio is actually the ratio of the width of the rocket to the height of the rocket. And normally the optimal fineness, about as tall as you want to be to your width, is about 15:1. And Falcon 9 is now at 18:1. So it's very long and thin. Now it's only 3.7 meters across. Why did he pick 3.7 meters? Because it fits on highways. He wanted to build his rockets in Hawthorne, California, and he needed to fly them from Florida, and you got to get them there somehow, and so it fit on a long flatbed truck so he could truck it. That's why it hit 3.7 meters. The fairing on it is only 5.2 meters, which limits the size of the payloads you could put on it. You couldn't fit any space station components on it. It's not large enough. And you can't make the fairing any bigger because you've already tweaked out the fineness to the point where if you make this rocket any longer or heavier at the end, it'll fold in half in flight, and that's bad for the mission. So Falcon Heavy's kind of stuck. They need a wider rocket. Now, Elon being Elon, he's jumping the gun. He's going from a 3.7 meter rocket to a 9 meter rocket, right? That's also supposed to be completely reusable and have 37 engines on the base stage. So, I mean, if he pulls it, this is the guy who, flew the dude in space, right? So, yeah. I mean, if anybody can pull it off, it's this guy. So I hope he does it, because that 100% reusable rocket drops the price of spaceflight massively. Before SpaceX, it was typically $20,000 a kilo to low Earth orbit. Right now, today, on a Falcon 9, it's $1,800 a kilo. If spaceship works the way it's supposed to and it's fully reusable, it's 20 cents a kilo, because it's just gas at that point and some maintenance. So I like that he's going for it. I just think he's skipping an important step, right? He wants to go to the moon. There was a guy, a billionaire, who apparently lost 25% of his net worth, so I don't know if he's still a billionaire, who wanted to go to the moon, but he's going to wait for Starship now, so that's not going to go anywhere. So let's talk about the other tech billionaire. So our friend Jeff Bezos, the wealthiest man in the world, has been spending $1 billion a year in Amazon stock on Blue Origin for almost 15 years now. He just doesn't talk a lot about it because he's completely self-funded. And his current vehicle is a vehicle called New Shepard, which is a suborbital rocket. It's quite small in comparison, but it has flown above the Kármán line, and then the booster has landed back on its tail repeatedly. And they've flown the same rocket 4 times in rapid order. He's building a larger rocket. It's called New Glenn, and it is a 7-meter rocket. So he's going from having never flown into orbit to building one of the largest heavy-lift orbital class rockets ever, a rocket I think Elon could build without any challenge at all, but Elon's going for that even crazier step. So this guy's going to have to take his chances with never building an orbital class rocket before, and then building this gigantic one in the form of New Glenn. And he too says he can land the first stage back on a ship. And he bought the ship. It's actually a full-size roll-on, roll-off cargo ship they're converting. It's about 5 times the size as the thing that SpaceX lands on, but that's because the rocket is more than twice the diameter. It's an enormous rocket. But it should be, and they're serious, like they've broken ground, they've been under construction, but largely secretive at Kennedy Space Center. They have rented a pad, and they've been building huge structures. Things have been going in, but nobody really knows where he's at. We do know he has an engine, that he has built a methalox engine called the BE-4 that has sufficient power to build a rocket of this class. Blue Origin also has been talking for a long time about a project called Blue Moon, which was that they wanted to put landers down on the moon to provide supplies for NASA. And earlier this year, they showed a design and a beautiful mock-up of a lander supposedly capable of landing 6.5 metric tons on the surface of the moon. Now that's less than half of what the Apollo lunar exertion module could land, but more durable, safer. This is enough lift that they could put 4 decent-sized rover down at once. They would need to double this size to get to the point of being able to put humans on it. But along with that Blue Moon plan was a fairly detailed study of building a base on the South Pole. So different landing zones, because you're not going to be that precise, places to put resources down. Notice they were talking about landing approaches, because they need to map out the gravitational effects across those approaches so you can get precise landings done. And this area is the southern edge of the Shackleton Crater, which is right on the South Pole. In fact, they're including the South Pole in this drawing. And why is that interesting, landing right on the South Pole, especially the Shackleton Crater? Well, here is an animation of the Shackleton Crater. And you should ask the question, who took this picture? The Lunar Constants orbiter took this picture over a period of 2 years. And so it really mapped out an entire year's worth of lighting around the Shackleton Crater. And the two things you notice is that the center of the crater, which is kilometers across, all of Sydney would fit inside this crater, is always in the dark. And there are portions of the rim of the crater that are always lit. So if you were going to go solar power, this is not a bad spot, and you're right by the ice. And the crater is very large. It's hard to convey how big this crater actually is. Now, solar power has its limitations, because you do have that day-night cycle, and so there is developments on the nuclear side. This is a reactor called the kilowatt reactor using Stirling technology, or crusty, because, you know, nuclear scientists can be funny too. It's about a 10 kilowatt reactor. This is a drawing of it. The reactor core is down in the far end here. It's about the size of a roll of kitchen paper or paper towel. It's basically a solid state reactor. You have a control rod you put in it, and then you pull it out when you're ready to start, and then it runs for about 20 years. Basically, no further work needed to be done. It's mostly cooling fins, so it puts about 10 kilowatts of electricity out and 40 kilowatts of heat. Both things you need on the moon. The prototype is running at the Glenn Research Center outside of Washington, D.C. So this is actually a maturing device that could be flown in the near future. Now, what would we do on the moon while we were there? Well, we can build manufacturing plants. And we can manufacture things like solar panels. All of the ingredients, the silicon, the titanium, exist on the moon. So if you can figure out how to mine it and refine it, you can start manufacturing solar panels. Now, there's a Japanese proposal to basically cover the moon in solar panels. Looks cool, probably not a good idea, and you have to send that power back to the Earth, which is a bit far to go. So better to build the solar panels on the moon and then send them back towards the Earth to something like this. This is a space-based power station. It's called SBS Alpha. And this would be about a 10 kilowatt power plant in orbit that would beam the energy down onto the surface. So the receiver would look about like this. We've been able to build this for quite a while. It's just too expensive. But manufacture on the moon might make it cost effective. We have a space station. That space station has taught us a lot about how humans live in space, mostly that we don't do well in free fall. So we need to, if we're really going to fly to other places in the solar system, we need some gravity. There's a design based on the space station called Nautilus X, which has a rotating donut, which can provide gravity. The question is how much gravity we actually need. And if you ever watched The Martian, you saw this. This was the Hermes, which had modules that were part of a rotating ring. If we have to make 1G, the ring has to be very big, 50 meters across. But if we could function in a lower amount of gravity, we could do well. So one of the things we can do on the moon is we can put humans up there for a year and see how they do in 1/6G. And if they're healthy, we can build 1/6G rotating rings. In fact, you could actually vary the rotational speed. So if you want to get conditioned to Mars, go to 1/3 G. All right. The European Working Group, the International Space Consortium, this is what started this whole talk in the first place, actually proposed being on the moon. On the South Pole, they wanted to use inflatable habitats. Then you use robots to bury them in a meter of regolith for radiation protection. And then you could put people down on them after they were built to some degree, which is an interesting design. Good enough place to do laboratory work. It's very much like Antarctica in that model, which for the most part, there'd only be scientists down there. Although you can take a tourism trip to Antarctica, it's just really expensive and lots of penguin shit. I know, people have told me. So it would be interesting to look at what that would look like, that we get to a point where we have enough bases that we could start having individuals actually on the moon. When Elon draws this, of course, he draws something that looks like, I don't know, Burning Man? Actually, when I saw this, I thought Space 1999. Anybody remember Space 1999? Okay, only the old people. By the way, you can find this show in like Netflix stuff. Don't watch it. It's terrible. Your childhood memories of the show are vastly superior to the reality. This was a show about humans storing nuclear waste on the moon, and then it accidentally blows up and pushes the moon out of orbit and into all kinds of aliens who apparently were hanging around nearby. I don't know. Anyway, a surface-based moon station is probably unlikely just from the radiation and micrometeor exposure. But remember we were talking about the volcanism on the moon? Well, we already have evidence that there are lava tubes on the moon. This is a thing called the Marius skylight. And that opening's about 40 meters across and more than 80 meters deep. They think there's a tube running kilometers connected to this that's at least 30 meters high and solid rock. Like, there's every expectation that you could put a plug at each end and pressurize it. You get your radiation protection, you get a huge structural space to work in, and you get your micrometeor protection. Sexy? No. But this isn't science fiction, this is science fact. So it gets a little less sexy that way, right? It makes sense to build stuff under here. Put inflatable structures in, you can build a lot. The Japanese have a mission called the SMART Lander, supposed to fly in the next couple of years, specifically to land beside the Marius skylight. Not in it, because that would be a problem, but beside it. So precision landing, super important, one of the things the Japanese are working really hard on. And they were thinking it might even be a hopper, so they might be able to take some sensing around it and then maybe try and fly into it and see what they could find down there. Other missions we could do on the moon. I talked about human sciences, learning more about how the body functions in 1/6 of a g, which really opened the door to us sending humans further afield, because we can't do it without at least some gravity. We just don't know how much. We talked about doing manufacturing on the surface of the moon, but there's also a lot of science we could do. The National Laboratory, National Naval Laboratory, the US Naval Laboratory, proposed using robots to lay out large sheets of capon across the far side of the moon to build giant radio telescopes. Knowing that from the far side of the moon, all of the electromagnetic noise of the Earth is blocked. So they should be able to see very deeply into the greater universe with an array like that. It's a cool experiment. We've also never really dug deeply into the ground, and you never know what you're going to find in the ground on the moon. All right, old people laughing, I get that. This is from 2001: A Space Odyssey, movie put out in 1968. Before man had landed on the moon, Kubrick had already built this incredible experience. Some argue the best science fiction movie ever made. It's also the first movie to ever use the phrase artificial intelligence, and then it tried to kill everybody. So we sort of set the gestalt right there. You don't know what you'd find if you dug down the moon. We've never done it more than an inch or two. Right? There's plenty of stuff to actually explore down there, certainly ores and so on. Every bit of technology we can develop on the moon, we can turn into things used elsewhere in the solar system. It makes a lot of sense as a spacefaring civilization for us to start mining asteroids, to take these asteroid bodies and take them apart and take their important ores out, mine and refine so that you can manufacture with it. We can learn that entire process from the moon, and with enough gravity that we have some sense of how to make things work, what will actually need to be in a centrifuge, what can actually work in 0G. And this is a proposed design where literally this machine comes up, clamps onto the side of an asteroid and just consumes it and separates it into its respectful ores that we can then put to work for ourselves. Learn how to do this, learn what kind of gravity we actually need, how to actually manufacture, refine, mine in space, utilize the resources in place, water, into both drinking water, fuel, electricity, power systems. You can start talking about Mars in a serious way. In fact, this series of steps to get to the moon could be emulated on Mars. There's a serious proposal to put a base down on Deimos, on one of the moons of Mars, before we ever try to land. Because again, easy target, we know how to do that. The landing part's a completely separate step. If we could actually stage materials and resources from that moon before we try and land on the surface. Everything we learn from working on the moon, we can carry to other bodies. And hopefully along the way we build out infrastructure that allows us to position resources. Take that power plant I was talking about, the space-based power plant, beaming microwaves down to the surface of the Earth for electricity. Something I think Blue Origin's very interested in, generating power, zero emission power from space. Take that same microwave transmitter, aim it at a spacecraft. Rather than hauling a heavy power plant around on a spacecraft, why not just beam the power to it? It accelerates up to speed, then you can go point at another spacecraft. So you start making your spacecraft simpler because they're reusing a common power source across multiple ships. Right? There are cycler orbits where you'd only have to get up to a certain speed and you'd continue to fly between two bodies repeatedly. Why put an engine on that? Have a remote engine that gets you up to speed, you don't use it again. The one slide that the NASA guys gave me and asked me to use in the deck was this one. Don't fear the moon. It's only 3 days away, plenty of water, some gravity, no weather. If you like this talk and you've never heard of the Geek Outs, here's a shortcut to the geekout.show. So you go there, it'll give you a list of all the Geek Out shows we've ever done. This one is in there, along with about 70 others. Thank you so much for your time.